We know that in electron configurations, we are concerned with the principal quantum number and the subshell. We don't really look at specific orbitals. If we are interested in looking at specific orbitals, we use what are known as orbital diagrams. And what orbital diagrams do is they depict or illustrate orbitals as either boxes or lines or circles. And electrons within these orbitals are represented by arrows for the up or the down spin. And this brings us to what's known as Hund's rule, which states that degenerate orbitals, so orbitals in the same subshell, want to remain unpaired as long as possible. So just to give you an idea of what an orbital diagram looks like, this comes from the textbook, and each orbital is indicated by a box, not because that's what the orbital looks like, but it's just what we use. And the electron configuration for hydrogen is 1s1, and there's an up electron in this box for the 1s orbital. Electrons have lower energy when they're in the up position, so if there's an unpaired electron, it's always going to be up. Helium has the electron configuration of 1s2. Both electrons are in the 1s orbital, one is up and one is down. Alright, and this also comes from a graphic from the textbook, and what it shows is the relationship between the orbital diagram and the electron configuration. And there's also, the last column shows the condensed electron configuration as well. So what I'd like to do is go down to the electron configuration of carbon. If we look at it, we see that there are 2 electrons in the 2p subshell. Well, those 2 electrons could be in the same orbital and be paired, or they could be in different orbitals and unpaired. According to Hund's rule, electrons in the same subshell are going to be unpaired as long as they can be. So if we look at nitrogen, which has 3 electrons in the 2p subshell, each electron is in a separate orbital, and nitrogen has 3 unpaired electrons. Once we get to oxygen that has 4 electrons, we have to start pairing our electrons. So oxygen has 2 unpaired electrons. Fluorine, which has 5 electrons in the 2p subshell, has 1 unpaired electron. And neon has no unpaired electron. It has a filled subshell. So orbital diagrams are useful ways for us to determine how many unpaired electrons there are. And unpaired electrons are important because they impact magnetic